Alright, let's take a look now at an integrated dynamic simulation and stress analysis example. We're going to start off here in the dynamic simulation tool. We'll utilizing a level of detail rep for dynamic sim, which removes components that are inconsequential to this analysis. Now, first step here is essentially to use unknown force to figure out what the force required is on this hydraulic piston. So we'll start by defining the initial starting position for that hydraulic jack. We'll select that right there. And now what we're going to do is actually place the load, a nominal load that we would see in the bucket. We'll essentially just split it between 2 points. Now we'll select the direction of the load and specify that the load is going to be associative. In other words, the direction of the load will move as the bucket moves. I'll do the same thing over on this side, again selecting an associative load, again 1250 newtons. So that gives us a grand total of 2500 Newton load in the bucket itself. So the only other thing to do now is to actually use the unknown force tool to run this entire mechanism through its range of motion. So we're going to go from 400 millimeters to 850 millimeters of extension on that hydraulic jack. And the unknown force tool will tell us exactly how much force is required at any point during the entire range of motion. So as you can see, we're looking at almost 41,000 newtons of force required to get this thing going. And once momentum is on our side, that and the combination of having a good mechanical advantage as it runs through its range of motion means that the required force gets lower and lower. However, we do have that initial requirement of like almost 40,500 newtons. So what we'll do now is we'll actually go ahead and plug that value in as our as the value we will use for the strength of this hydraulic jack. Now this is valuable from a purchasing standpoint because we could now use that information to select exactly the hydraulic cylinder that is required to lift this. So we'll put in that strength of 41,500 newtons. We'll give ourselves just a little bit of overhead because the unknown force tool essentially just guarantees us equilibrium, static equilibrium. Now what we do now to pass the resultant forces to a single part is to essentially select that part as being exportable for FEA. Now, because this part is a component in a subassembly, we need to set the entire assembly to flexible so that we have access to that single part. So now we'll select Export to FEA again. We'll select the part. And now essentially what's going on is the dynamic simulation tool looks at that part and looks at the joints, the dynamic simulation joints, which act upon that part. So there's a welding joint, which is essentially the constraint that holds that together with the rest of the assembly. And then there's the revolution joint, which is the point at which the hydraulic cylinder exerts all of its force on that component. So now what we do is run the entire simulation through its range of motion. So as you can see, the hydraulic jack is extending. We're only running for about 1 second here with 100 time steps. The time steps basically give us the breakdown or either coarse or fine accuracy on the requirements. So now we're looking at the force on that joint, which was revolution 14. We can see that we have an exerted force at at the high point, our maximum force, and now what we're doing is selecting forces at 2 other time steps. So in the entire range here, you can see here's the part itself, the 2 joints that act upon it, and then here are the time steps that we're exporting. So at half a second, 3/4 of a second, and 1 full second. So the forces at those time steps have now been exported to that component. So the next step now is to actually go over to the stress analysis environment, where we will set up a stress analysis run using motion loads analysis So here are the motion loads that we just exported. We'll take the maximum force which was exerted on that component, which was at the 1 second mark in the simulation. Now, once this is done, setting up, we have a couple of things that we need to do. Here we can see the imported, you can see the icons there, the glyphs. Those are the imported moments of inertia. Those are the imported remote forces. So all of these came directly from the dynamic simulation tool. Now this is an extremely valuable way to use dynamic simulation because it obviates the need for using a free body diagram to figure out what